Right. Okay, then non-biased.
Okay.
That's why it is called bias, no? If one feature is more important, pretty much then the data is biased towards that. That is why they call it bias.
There are, in one sense.
So when you reduce the importance of that variable, so the bias is low, right? Something like this.
It actually is a correlation. I mean, it's a combination of all this.
So when you say impose some penalty on a particular variable to minimize the impact, then how does this calculation is actually done in the background?
What it does is, it uses some mathematical formula there. What it is doing is based on, it realizes, this class is heavily loaded. I explained this with respect to unbalanced classes, right? Okay, this class is more. If their data is accidentally getting classified here, the penalty of classification, they keep it higher. Why that? What I mean is some error cost, right? Error will increase more. Right? If the error will increase more, whatever it did now, it will try to undo that.
So that's the error reduction. There's the backpropagation. You can go for the backpropagation and reduce the weights.
And then that is what happens in any of the algorithm.
It is
some version of it.
It is not changing the data set, but internally it is doing something with the data.
Not with the data, with the coefficients that it is calculating.
Oh yeah. Okay. Yeah.
Let's see here.
But anyway, sir, that coefficient will be multiplied by the variable only.
Variable only. So variable it cannot change.
You can see the variable. The variable is that.
Okay, so let's come back here. So this is digits data set. Okay, apart from this data set, we have digits data. Digits data set looks like this. This is 0. Understood, right? Handwriting digits. This is handwriting data set. So this is present inside.
Just random digits.
Yeah. Okay, so this is digits data set. I'm importing this. Okay, load digits if I do, right, and if I'm importing the visualization library, plotting library, and it is the first data. This is the, you can see the values are between 0 and non-zeros, right? You can see this is non-zero means some you can do the reverse also. Non-zero means some lighter thing. Alright, right? This black 0 0 is black.
Yeah.
Understood? You can see a 0 here, isn't it?
Yeah.
And this is the thing that gets represented if I do the CMap play. IM show. If you have an array of data which you want to numpy, which you want to visualize, right? Matrix or numpy, you can do this IM show. Got it, right?
Then 0 it is taking pure dark. 1 it is little.
Yeah. Right. Grayscale. This one is grayscale.
Okay. Classifying the data.
Not yet. I'll explain what it. The data consists of. This is the data part. This data consists of 1700, I think. Yeah, and this is the digits part, right? Digits dot data. The digits dot target consists of. If I do digits, what will be the data? Digits dot target. Any guesses? What will be the first? This is handwriting data for numbers. What will be the possible target here? Not target. See, this is the data concept 2 parts, data and target. Data is your actually handed, huh?
What you
trying to predict, like target will be 0 to 9. If first data was 0, right? See here, first data is 0. Understood?
This target is a color. Target is a color. How dark or how light it is.
Hey, target is a number.
It's just numbers, man.
Predicting
the handwriting. See, you write something, right? And you predict. If I've written 1, algorithm should predict it as 1. Okay. Just try to read that format, like how it is. You do it in neural network, I think. MNIS.
This is MNIST.
MNIST only. But neural network is best for this.
Yeah, I mean, this is simple data, so this way also works. There is, I will give you assignment for using fashion names. No, that library is not available. that is available in Keras. Fashion and list. There are here you see digits, right? There it is clothes.
Oh.
You will identify clothes.
If it is 1, 2, then what will you predict?
Huh?
If it is 12.
12 is not there, only single 0, 1, 2, right? You heard this? This was actually dates back. This was the first case with NIST. In US, postal code was identified using computer imaging. This was first algorithm there. Postal code. Okay, there means a letterbox given postal code. Based on this, it will be routed where it should be going. In a machinery, right? It will identify this, where is this postal code, and it will route it.
I'm still so scared of it. What? I mean, if it does it wrong, it will go somewhere else.
It goes somewhere else. Then there is a manual thing.
Doctors can never use it.
That's why it is for assisting. It's not that, the accuracy is 99.94. It is more than human accuracy, right?
Quite good, yeah.
They sell, there are a lot of debates around it, but
if you 100 days, but seriously, sometimes we can understand what the person is written in that.
Yeah, exactly.
I don't know how the computer understands.
So error is still the same. So here there are a lot of digits which we can't understand.
But it doesn't take only the numbers, or it will take.
It is the data set is only for numbers. You can do for other things as well.
In bank, your signature pattern is verified by. No, what I was saying is that if someone could identify a code, okay, he can also see that which location, other variable. Then you realize, oh, definitely, like if there's a doubt, then definitely you will know, okay, this becomes to be same.
Oh,
the other variables also come to the picture.
That is. I'm just talking about numbers. So this was understood. This data, this entire data set. The data set consists, I think, 1797 digits. Okay. Now, what are you doing? You are actually splitting the data into train and test, right? So that you understood, right? Splitting the data, why it is required. So now you are splitting the data here in this line. Creating a decision tree, you are doing a decision tree fit on the training using the training data. Then score function is there, which will find the accuracy score, right? Okay. This is, see, testing data accuracy is 84 and training data accuracy is 1. Overfitting. Oh, it's really overfitting actually. So what would you do? You would basically put a next thing. That is what we have done. Right? If you see this tree, it will be a lot of branches. Lot of branches. I mean, if you want, I can show that. But you cannot see the tree in one scale. You have to scroll down and all that. You actually should see that.
Inside that box, what code you are pasting?
Oh, you didn't see that?
WebGraph.
Oh, WebGraph. Last time I went to experience that the code. Oh, let me show them. This was the website. Okay.
Do we have similar browser like something like Graphis? To generate the decision tree? Do we have similar things? Or this is the only one that we have to use?
I know only this one. There might be some other stuff also. You might not be aware. Never explore.
This DT is generated already. This DT is generated.
Yeah, there was earlier. Now we also generated something, right? Out. No, what was that? What is the file? Tree dot, huh? Yeah, this is the file.
This is the file which is generated after the running the algorithm?
You want to see the tree?
Oh my god.
It's still not coming in my screen. See?
No. Only computer can do this. Only computer can think like this.
Okay. Okay, that's the and you can see it overfitting here, right? So what you do here, you basically minimize the depth of the tree to prevent overfitting. You can see now training accuracy and testing accuracy is pretty not that bad, pretty close to each other. Maybe a little more here would actually make them in the same stuff, right? So after you can plot a tree now, the depth will be 6 only. Right, not only the regression, the classification, you can use decision tree for regression as well. Okay, the question that I have for you guys is, how do you use a decision tree for regression? See, based on the question, you try to create it, and it eventually finds out where exactly it belongs, right? How far is the tree? Like, let me generate for regression. There's 4 columns, train test. Right? We have this REG red start, right?
Is there?
See here. This was the first question, is it? Column number 3. Based on the true value, it reaches here, right?
Mean squared error.
Right, and reaches here, say reaches here, somewhere a value, it reaches here. So that means if this is the case, this is the MSE and this is the value, right?
Is it classifying on the basis of MSE?
Huh?
What is MSE?
Mean squared
Mean
error.
squared error.
Mean squared error.
Okay. If this is the mean squared error, this is the value. If this is the, so what it tries to do here, you can see it is not Gini here this time, right? What it tries to minimize is the mean squared error. That becomes a parameter. And
that is what we do in regression.
right, mean squared error for regression.
Reduce the mean squared error till the time.
Yeah.
Right.
Match.
So when the mean squared error comes the least, that time
that is what you are trying.
How many the layers it will create, it depends upon that.
Here, how much max depth you are passing.
So let's say if I have a scenario. So I have a data set which includes the age of an employee, the experience that he has, and the skill set, and we are predicting the salary. So even there also we can use the decision tree. It will be one.
Okay, so though for regression, very less people use decision trees. Not much popular. Classification it is more popular. Right, make this note. This is tree-based stuff. It is good when the data is non-linearly separable. If the data is large, decision tree works well. It might take a little more computation time, but decision tree works well. Right. So one more module, one more. So now you can understand that different data means different trees. Okay, so that is the problem here. Right? If you use same data in different order, also it will generate different trees. What you need is basically from same data you want multiple trees to be generated so that you can generalize it, isn't it? Right? If that was the situation that same data is generating different trees every time you're running with different order of data, if you generate different trees, you can generate different trees from same data. Right? By changing the order, you can do that. Right? And this will help you generalizing it. So, and what happens in decision trees is all the important questions comes up, right? So you can take important questions from one tree versus important questions from another tree versus important questions from another tree and create a random forest. So So that is what random forest is. Random forest means basically you are combining different decision trees using something out of it to create one. Random forest is a part of ensemble method. What is ensemble? Or people call it with different names. Ensemble, ENSEMBLE. Okay, the actual pronunciation is ensemble. Ensemble means you are combining different base or weak algorithms to create a stronger algorithm.
Can you explain again the random forest?
So random forest.
It just went out.
So random forest is basically, I should have this in GitHub, right? Okay, random forest is an ensemble method.
You have it in GitHub.
This file is there, huh? Random forest classifier, this whole code.
Random forest quicksets and the other is random forest ensemble techniques. In GitHub. Okay. Can you share these files?
I need to upload, I guess. I haven't done that. I mean, a lot of trainings that happened recently. I created here, but I'll do that today. Huh? It is ensemble method. What is ensemble method? Ensemble method means combines different technique to create a new technique. So what are we doing here? We are combining different decision trees to create a new technique here. Different order of same data means different decision tree. This is what I spoke. Okay. Combines different trees to create a forest out of it. Okay. Internally uses multiple decision tree to generate a forest. Okay. Now this is bagging method. Bagging method means it will combine different trees. So there are two ensemble methods. One is bagging method, one is boosting method. Okay. Bagging method means you combine different decision trees and create one random forest. Okay, that is a bagging method, combining things. Boosting techniques means you have a linear regression method. Based on linear regression, you predicted its coefficient and all that. Now you will realize in boosting technique that if you modify this parameter by this much, you are getting very good accuracy. That is known as boosting method.
So it's trial and error.
Not trial and error. I'll explain the boosting method concepts separately. I'm just giving a heads up that there is another set of problems that we'll discuss, that is boosting. Okay, I'll discuss boosting in separate class. But yes, what happens in random forest? Random forest is a bagging method actually. Bagging method means it uses different techniques, combine them together. That's the bagging method. Another such example is voting classifier. Okay, voting classifier. So I'll discuss that also when I discuss ensemble methods as a separate topic. Just for completion, I'll explain random forest now. So this is random forest classifier. It is random forest classifier. Random forest is both regression and classification. Again, more popular for classification. And here you can see the same digits data. Remember, right? We got an accuracy of 80s. Best accuracy of 80s, around 80s we got. Huh? So here number of estimators. Let me do that. Right? Number of estimators 10 means 10 decision trees. Understood, right? Then you are loading the data. Then train test, fit, score. See, test score itself is 90% here without doing anything at all. Okay, you want to try few more things. See, test data. This is well trained data. See the accuracy now. Right? So remember, if the data is less, decision tree is not that good, your random forest works well. Got it?
So what is the 10 decision trees?
10 decision tree means it will, from the same data, it will internally create 10 different decision trees.
It will create 10 different
decision. Then from those 10 different decision trees, it will take important features, very important questions, then create a forest.
It will just change order of the row or something?
How it will, yes, exactly, that's the next question. So suppose you have to generate 10 different decision trees from same data. You basically would actually divide the randomized data set, divide the data set into 10 different parts. You'll use 9 parts in one time, 9 parts in the understood, right? You basically would change.
So randomly they are just doing
right.
And then they are combining this 10 different decision trees, make one random forest.
Right.
Like, what do they take from this decision tree? What is it they pick up from the decision tree?
From this decision tree, it figures important question.
Okay.
Because each decision tree gives you important questions here, right? So here it is figuring out important questions for you. What is my features in this data? What are my features?
Avantik, one question. You say the score is 87 or 95%. It's because of less data.
Come again?
Did you say the score is 94 because of less data?
No, data is same as we used in linear in decision trees, but we used random forest this time.
Yeah. So you said like the score is pretty good, like because the data is less.
No. What I said is, for lesser data, your decision tree might not work that well. Okay. So we used random forest in this case.
But still, like say, on the basis of concept of decision tree, right? This is the question. So it has to. The score should be like given importance, or it is relevant, right?
Coming.
Irrespective of the data, less or large data. So on the concept of decision tree, so still the score is relevant, right?
Oh, this is not decision tree.
This is random forest.
I'm sorry. Yeah, it's random forest on the basis of random.
What he's asking, irrespective of your number of samples, whether random forest is the best option.
No. That's the point I said that, right? So if you have lesser data, your random forest works out pretty well, and it is more computation intensive. Random forest. Decision tree is good if the data is large.
Yeah.
Right? Decision tree with limited height. That's good. The data is large. And so remember, what is my features? If I may ask you guys, what is my feature when I'm doing the training? What is my feature here? What is my target? How many columns are there in the feature? I give image data. This is actually image data.
This is the digit data, right? 9 columns.
Hey, my feature data. How many columns are there in
9 digits? 9.
Okay.
64.
For this random forest.
The rows will be mentioned, the columns no.
Digits.data. If I do digits.data, see, this is each row is a image, right? You basically reshape into 8 cross 8 and it will be an image. And what will be the shape of it? You can see 17, 97, 64. So number of features is 64. So you can imagine if there is an image of 1024 plus 1024, what will be the number of features? 10 raised to the power 6.
This one,
10 raised to the power 6. Understood, right? And this is nothing. Okay, that is why you need things like, and you need to do image extraction, or you might use deep learning.
I mean, you just said that is about one image, right?
That is one image.
They are like in thousands, infinite number of images.
Right, generally. Okay, so that understood this point. So now random forest has a very useful stuff actually. A random forest have this function. Today only I was feature importances. Right, if I do this, see here, it will give you importance of each feature. Understood? Okay, if you want to, this is each pixel anyway. I mean, this is very simple data, each pixel. This is the importance of each pixel here. Understood? Similarly, in the below example, see here, basically, you want to find out which are the important pixel. It is doing this. Yeah, these are the important pixels. Yeah, these are the important pixels here. Understood? But but to understand it better, I'm downloading another data set, California housing. This is a housing data set. Okay, it has some 20,000 rows, 8 columns. These are the targets. Housing means house price. 4 columns are there. Random forest and train test validate. Feature importances. Yeah, there it is. Feature importances. Do you notice this? It means that this first column is very important.
But here you are like, unlike the other, here you are not giving any criteria. Then how it is figuring the important features?
That's why random. That's what I said. What does random forest do? Random forest picks out important questions from automatically from all the decision trees. So it knows if whatever question is there, it is using some column more often, then that is important, isn't it?
And it is based upon
different decision trees, right?
It is like bit advanced, like after decision tree.
Right. Understood, right? That is why. So what you do, you realize that this column is important, this column is important, the others are okay, not that great. So can I do the training with these two columns only? First and 0, 1, 2, 3, 0 and 5 column. Let's see. So if you see score, okay, so if I do this rf dot fit train X, what is the column that I'm interested in? All the rows. 0. That 0,5. I have to
segregate the data line.
No, then that will take 0 to 5.
Yeah, just a second. Next is this, right? So you basically need, see, this is the 0th column.
Yeah,
this is the 0th column. This is where your NumPy skills becomes useful. Which column? 5th column. Right. NP HStack. Wait. Horizontal stacking. Index size is out of range. Size 4.
So it's 4th, I think.
Hey, why it is 4? Achha, I think, see here itself I am selecting only few columns.
Yeah, 0, 5.
Right, so here see housing data dot transpose, selecting the columns, and again I am doing dot transpose. Okay, so that's why housing data. Okay, so
why transpose?
see if I do transpose of it, these are like short,
This is coming in
rows, then we are selecting those and popping it up. Got it, right? So basically, so now the algorithm, anyway, I'm using this now. So see, the accuracy is 78%. Just by using if I want to use on more 2 columns, then it came down very badly, right? $63. Understood, right? See, on adding each feature here, you're getting 79, right? Among all the other, you understood, right? And we chose this thing based on the feature importance. We use this column, this column, these 2 columns. Okay, so these are things around random forest. You can try solving some problem in random forest from the list, right? From the UCI dataset. This is another way to.
So please share this video at least.
At least.
No, I'll upload it. Today's and last Wednesday's class, right?
Yeah.
I'll do to both of them. Yeah, okay. Stop it.